Good evening to everyone. Today we are going to see a problem which explains application of Clausius equation. So it is about an ice skate. So an ice skate is able to glide over the ice because the skate blade exerts sufficient pressure on the ice so that a thin layer of ice is melted. Skate blade then glides over this thin melted water layer. So we have to determine the pressure an ice skate must exert to allow smooth ice skate at minus 10 degrees Celsius. So the below data is given for range of temperature and pressures involved. HFG for ice, that is the latent heat of melting for ice, is equal to 334 kilojoules per kilogram. Volume of liquid ice is equal to 1 into 10 power 3 meter cube per kilogram. And specific volume of ice is 1.01 into 10 power 3 meter cube per kilogram. So as this problem involves phase change, we can use the Clausius Clapeyron equation as given below. So rate of change of pressure with respect to temperature is equal to HFG by VFG into 1 by T. So we will multiply both sides by dt so that the dt in the left hand side will get cancelled. So we will get integral P1 to P2 dP is equal to HFG and VFG are constant, so they are kept out of integration. So HFG divided by VFG integration T1 to T2 of T dt by T. P2 when we integrate dP, we will get P. That is, so when you integrate this dP, you will get P. Then the limits P1 to P2. Similarly, so this HFG and VFG are kept out of integration. HFG divided by VFG. So these two are kept out of integration. So when we integrate dt by t, we will get log t. So limits t1 to t2. So we will substitute upper limit first and then lower limit. So the left hand side will be P2 minus P1 equal to HFG and VFG are there. So log of T2 minus log of T1. So we can write it as log of T2 by T1. So these are the values. The initial pressure is 1 atmosphere. That is when before the melting at melting point of ice, the pressure is 1 atmosphere. It is 1.013 bar, and the temperature in terms of Kelvin is 273 Kelvin. Similarly, the final pressure, that is what we have to find out. So T2 is equal to minus 10 plus 273, 263 Kelvin. So from 263 Kelvin to rise the temperature to 273 Kelvin, what is the pressure required? That is what we have to find. So the pressure when at which the ice will melt. So P2 minus P1 equal to 334 into 10 power 3. That is HFG is 334 into 10 power 3 and VFG is 1 minus 1.01 and log of 263 divided by 273. So we will get minus 0.01 here. That is, the next step will be like this. Next step will be, this will be equal to 334 into 10 power 3 divided by 1 minus 0.1 is minus 0.01 into log of 263 divided by 273. So when we interchange this 273 to 263, another minus sign will come out. So this minus and another minus will cancel and will be positive. So I just in the next step they have interchanged this numerator and denominator. And, there will be another minus sign. So the minus and the minus sign in the denominator, this denominator will get cancelled. So the next step will be 334 into 10 power 3 divided by 0.01 into log of 273 by 263. It will be equal to 12.46 into 10 power 5 Newton per meter square. That is P2 minus 1.013 into 10 power 5 equal to 12.46 into 10 power 5. So when this minus 1.03 go to another side, P2 will be 13.47 into 10 power 5 Newton per meter square, or 13.47 bar. So what does this problem convey? So for this skate to sail smoothly, the thin layer of ice below the skate must melt. So for melting, how much pressure the skate must exert on this ice? So that is what the question is asked. So to maintain the skate at minus 10 degrees Celsius, when you want to skate smoothly, so the pressure exerted by the skate should be equal to 13.47 bar. That is 13.47 into 10 power 5 Newton per meter square should be exerted to melt the ice from minus 10 degrees Celsius to 0 degrees Celsius. That is for supplying this latent heat. So for the melting of ice, HFG of 334 kilojoules per kilogram of heat must be supplied to that ice. For supplying that heat, pressure must be 13.47 into 10 power 5 Newton per meter square. So this problem explains the significance of Clausius Clapeyron equation, that is dP by dt equal to HFG by VFG 1 by dT. This is the Clausius Clapeyron equation that talks about rate of change of pressure with respect to temperature whenever the phase change happens. So this equation is important to adjust the conditions when there is the pressure change and phase change. Right? Thank you.